Good evening, friends and neighbors. This is Mr. Leavenworth one more time, coming to you with your last video of this sequence regarding limits. We've talked so far in class prior to these videos about graphically analyzing limits. Then we talked in our first video about substituting in algebraically, and then in the second video we talked about what happens when you can't just substitute straight in. This video is a little bit different. We're going to be talking about these things called one-sided limits. Sometimes it is advantageous to take a limit just from the left side or just from the right side, and I'm going to show you a few examples where that might be the case. Before we get there, just check your notation. This is kind of a weird thing. You will sometimes see a plus or a minus in what we call the superscript or that exponent position. If you see a plus in that position, that means we're taking the limit from the right-hand side or a right-hand limit. If you see that minus or the negative sign in the exponent position, that means we are taking a limit from the left-hand side. And I'll talk about what that looks like in problem number 6 on this page right here. So you see I'm asking for 3 limits right here, all centered on -2, and you might realize, ooh, something weird is happening in this piecewise function at -2. And that's exactly why a left-hand limit and a right-hand limit are sometimes the most appropriate. So 6a right here is asking for, okay, I need the right-hand limit because there's a plus there, the right-hand limit. So that means I'm going to come from the right-hand side and kind of almost imagine yourself walking on this line. And as I get closer and closer and closer and closer and closer to x equals -2, what y value am I getting closer and closer and closer and closer to? And the fact that the function is not defined there really doesn't bother us because it is very, very clear that up until that actual x value, we are getting closer and closer to a y value of -2. Now in 6b, it is asking for, because the minus sign is in that exponent position, a left-hand limit. And that just really means we're doing the opposite. We're coming from the left-hand side. And so again, imagine yourself kind of just do. This might be a little more fun to walk around or maybe a little more dangerous, but we're coming down and we're getting closer and closer and closer and closer to x equals -2. And we get to this point if we're approaching from the left-hand side, and that corresponds to a y value of 1. Here's the tricky part, though, is when I just ask you for a straight limit with no left hand or right hand involved, what do we notice here? Well, if I'm coming from this side, the left side, my function approaches 1, but if I come from the right side, my function approaches -2, and in the words of Katie Heron from Mean Girls, in this case, the limit does not exist. In order for a limit to exist, the left-hand limit must equal the right-hand limit. Learn that phrase, love that phrase, maybe even tattoo it on your arm. It's worth knowing in calculus, and it will come up a lot. In order for a limit to exist, the left-hand limit must equal the right-hand limit. We'll talk more about that as a team in class as we get into continuity and some other fancy concepts like that. I hope that helped graphically. There's also a way to talk about one-sided limits algebraically, and I've got a couple problems here, 7a and 7b. I'm going to ask you to try those on your own outside of this video, but letter C gets really interesting because it's a piecewise function, actually very similar in structure to the graphical function we just looked at. And maybe you can take a second and think what this limit is asking. If you could maybe even read that limit to yourself. How would you say it in words? Okay. So we would say the limit as x approaches +2 from the left-hand side. And that's cool, and if I had the time or the mental fortitude to graph this piecewise function, I could totally do that, and I could look at what's happening from the left-hand side, but I don't, and I'm not going to, because I have enough information in the structural equation here to do exactly the same thing and take a lot less time to do it. If I am looking for the left-hand limit as x approaches positive 2, the left-hand limit, where would I plug 2 in? Would it be the top line, the bottom line? Would it be both? And how do you know? Well, in this particular setting or situation, think of the number 2 on a number line. This piecewise function is saying, hey, for any value over here, I'm going to use the top line. And for any value, including 2, and to the right of it, I'm going to use the bottom line. But here's the thing. Because I am approaching positive 2 from the left-hand side, I am going to use the pink section or this top line. So I can simply say the limit as x approaches positive 2 from the left-hand side of f of x is equal to, well, 2 squared minus 4 times 2 plus 6. And that is coming from here. That positive 2 is what I am using to plug in a substitution manner for x. And so I can just keep going. I can say that limit expression is equal to 4 minus 8 plus 6. And if my elementary school arithmetic serves me properly, I'm thinking that is equal to 2. Now, it's important to note, if I was looking for a right-hand limit, if that said the limit as x approaches 2 plus or 2 from the right, I would be using the bottom line because I would be coming from this side. Again, we're going to get a lot more practice as the week goes on, but I appreciate your time watching these 3 videos. Hopefully you've watched all 3, and if you haven't, please go back and see them all. And it was wonderful working with you. Again, if you're not one of my normal students, you can always ask questions. You can reply to this YouTube video. You can reach out via email. Any of that or all of that is totally okay. Thank you again for your time. I'll talk to you soon. Thanks, everybody. Bye-bye.